Okay, so we've been graphing rationals for the last few days, and I decided to go ahead and do it to go ahead and break it down as a play-by-play type of a thing. So this first topic is going to be horizontal asymptotes because that's what we normally look for first. So here we have a function. Okay, here let's go back to this slide here before we start. If you notice on this graph, all kind of stuff is going on, but what we're interested in is this right here, this green line. This is our horizontal asymptote. So notice that the purple function gets super close to it, but it never touches it. That's what an asymptote is. It's a line that they get super close to but never touches, and this one happens to be horizontal, so that's our horizontal asymptote. So we're looking at this function here, and we want to know where its horizontal asymptote is. Maybe it has one, maybe it doesn't, but we want to find out. So there are 3 rules in finding horizontal asymptotes. And all of them involve looking at the degree of the function. So if you look at this top function, just this part right here, we have x plus 4. So the degree of that, and if you remember last unit we had like ax to the n, where a was our leading coefficient, and our n is our highest exponent, that's our degree. So when we're looking for our horizontal asymptotes, we need the degrees of the top and bottom functions. So the degree of this top one, and I'm putting t for top. Just don't have to write out top every time. So our n sub t is just a 1, right? Because this is like an understood 1. So the degree of the top is 1. Then we look at the bottom. The degree of the bottom, our highest exponent is a 2. So our degree of the bottom, b for bottom, equals 2. Okay, so our rule says, so we have our degree of our top, we have a degree of the bottom. In this case, the degree of the top is 1, the degree of the bottom is 2, so it's less than. So if the degree of the top is less than the degree of the bottom, then you have a horizontal asymptote at y equals 0. That means the x-axis. That's going to be our horizontal asymptote. That's the rule. The next rule says that if the degree of the top is greater than the degree of the bottom, then you don't have a horizontal asymptote. So no horizontal asymptote. If the 2 are equal, then it gets funky. So if the degree of the top equals the degree of the bottom, there is a horizontal asymptote. And where we find that, so it's going to be at y equals. It's going to be a ratio. So in this case, we're going to look at our leading coefficients. Okay, I'm going to do this in green. So this is our leading coefficient of the top. This is the leading coefficient of the bottom. It's whatever is out front of our x that has the highest exponent. In this case, they're both a 1. It's an understood 1 because nothing's there. So a of the bottom is 1. A of the top is also 1. Remember, that's our leading coefficient over here, a times x to the n. So if the degrees are equal, your horizontal asymptote is going to be at y equals a of the top over a of the bottom. So in our case, up here, this is going to have a horizontal asymptote at y equals 1 over 1, or just 1. So let's look at some more examples. Okay, here are 3 examples. So the first one, we have f of x equals x squared plus 2x plus 3 divided by x plus 1. So we look at the degree of the top and the bottom. So our degree of our top is a 2 because we have our highest exponent is a 2. So that's this one right here. So the degree of the top is 2. The degree of the bottom is just a 1 because we only just have one x. So, oops, let me put that up here. Degree of the bottom equals 1. So this 2 is bigger than 1. So degree of the top greater than degree of the bottom. So looking back at our rules, so right here it says, that's this first rule in blue, it says if the degree of the top is bigger than the degree of the bottom, no horizontal asymptote. So this one is no asymptote. Ta-da! Now we could look at our purple one. We do the same thing. Okay, the degree of the top. Okay, so in the top we don't have an x, right? So this top part, we just have a 1. So there's no x. No x. That means that the degree is a 0, because anything to the power of 0 is just a 1. So then the degree of the top is a 0. The degree of the bottom, we just have an x, so the degree of the bottom is a 1. So in this case, our degree of the top is less than our degree of the bottom. And if we refer back to our rules, that's this top one in purple, degree of the top less than degree of the bottom. So we do have a horizontal asymptote, and our horizontal asymptote is the x-axis, so it's at y equals 0. Our final example, we have 3x squared plus 4 divided by 5x squared plus 2x minus 1. I'm going to do this in blue so it matches. Okay, so the degree of the top is a 2, because it's a square, right? The degree of the bottom is also 2, because it's also x squared. In this case, the degree of the top equals the degree of the bottom. So that means we're going to have a horizontal asymptote for sure. We just need to look and see what it's going to be. So for that, we need our leading coefficient. So we need the leading coefficient of the top is this number right out in front of our x squared. So that's this 3 right here. So leading coefficient of the top is 3. Leading coefficient of the bottom is the number out front. That's our 5x, or 5 that goes in front of the x squared. We write this in blue. Our leading coefficient of the bottom is 5. So then we have a horizontal asymptote. And our horizontal asymptote is going to be the ratio of these two. So it's at y equals a of the top over a of the bottom. So that would be 3 over 5. Okay, that's for horizontal asymptotes.